Hello everyone, and welcome to the very first episode of the AI Value Paradox. This podcast is brought to you by Kategos. If you aren't familiar with us yet, we're a team dedicated to helping brands navigate the complex, exciting, and sometimes confusing world of artificial intelligence. At Kategos, we don't just look at AI as a buzzword. We focus on the practical side, helping build strategies and tools that actually move the needle for your business and add real value to your brand. So why are we starting a podcast? Well, we wanted a better way to connect with the business and AI community. We're currently living in what we call a sort of value paradox, where there is more AI technology available than ever before, yet many businesses are still struggling to turn that tech into actual results. Our goal with this show is to bridge that gap. We'll be sharing deep dive insights, interviewing experts, and giving you actionable advice on how to stop only using AI and start using it to supercharge your business with actionable results. Enjoy this episode, and let us know your thoughts or insights in the comments.
Welcome to the Deep Dive. Today, we're unpacking a statistic that should, frankly, keep every C-suite executive up at night. We're looking at this immense, almost gravitational pull of AI's potential versus the profoundly disappointing reality of its execution. We're talking about the AI value paradox.
It is a profound paradox. And, the landscape today is defined by two wildly different realities. They barely seem to coexist.
Right.
If you look at the adoption numbers, they are overwhelmingly optimistic. A 2024 McKinsey survey showed that 72% of organizations are actively using AI in at least one business function.
72%. So it's not a niche technology anymore. It's mainstream.
It's absolutely mainstream. And with generative AI specifically, the projection is disruptive change across a staggering 65% of all industries. We're talking in the next few years.
And when it works, when an organization really gets this right and strategically aligns AI to a core business goal, the payoff, it's not just incremental, it's exponential.
It's transformative.
We're seeing these initiatives deliver an average ROI of 3.7 times the investment. And for those top performers, the ones who really crack the code, that return can skyrocket up to $10.30 for every single dollar spent.
That's the promise.
That's the definition of a durable competitive advantage right there.
But here's the profound contrast you mentioned. And it's the core of what we're calling the AI value paradox. This immense promise is starkly contrasted by one sobering, really expensive statistic.
Okay.
A staggering 85% of AI projects fail to meet expectations, are significantly delayed, or are just abandoned entirely.
Wait. 85%. Let's just put that in context for a minute. We know traditional IT projects already struggle. The Standish Group, they track this stuff, and they say that failure rate hovers around, 66%?
That's right, 66%.
But AI is failing at nearly double that rate. That's not just high risk. That suggests there's a fundamental systemic flaw in how we're approaching this.
Precisely. And that failure rate is the central argument we have to deconstruct today. If AI offers these stratospheric returns for that TAC 15%, why are the vast majority just crashing and burning and, frankly, sucking up budget? When you average everything out, the ROI for enterprise-wide AI initiatives is currently reported at a mere 5.9%.
So what you're saying is the handful of successful projects are basically carrying the entire financial weight of the industry's investment, while the other 85% are just hemorrhaging capital.
That statistical illusion is so powerful. You're absolutely right. It looks like AI is barely profitable on average, but that average hides the truth.
Which is that the successful projects are massively successful and the failures are total write-offs.
Exactly. And the crucial insight for you, the listener, is that this failure is not primarily technological. The models can work. The algorithms are powerful. It's strategic. It stems from a flawed technology-first approach. This idea that just buying the algorithm is the solution, rather than defining the business problem first and then building the necessary operational discipline around it.
Okay, so let's unpack that. Our mission today is to dive deep into that disconnect, the AI value paradox, and lay out a comprehensive strategy-led blueprint. If you're launching, planning, or maybe even recovering from an AI initiative, this blueprint is designed to shift your model, to shift it to one that's durable, value-driven, and focused on delivering that 3.7x or even that 10x return. We're here to talk about how you get into that 15% success bracket. Let's start by validating that foundational number. Is the 85% failure rate real, or is that just, industry hyperbole designed to sell consulting services?
No, it's absolutely foundational. And it's been validated across multiple credible sources, all focused on enterprise deployment. A 2023 report from Gartner cited this very alarming figure. They attributed it specifically to a lack of strategic planning and critically poor data quality.
Okay, so Gartner's on board.
And even institutions like the RAND Corporation, they did interviews with dozens of experienced data scientists and engineers, and they independently validated a similar figure. They concluded that over 80% of projects crash and burn. So the numbers is robust. The financial reality is that the vast majority of investment is being funneled into projects that are going absolutely nowhere.
Which explains that dismal 5.9% average ROI. The math checks out.
It does.
So the cost is real. But why is AI so much riskier than traditional IT? I mean, organizations are using standard project management, standard budgeting, standard teams. What is the fundamental operational difference that doubles the failure rate?
That is the key question. And it requires us to understand the fundamental difference in the nature of these projects. Traditional IT projects, think about deploying a new ERP system, building an internal database, migrating email services. They're largely deterministic.
Deterministic meaning what exactly?
Meaning they're built on explicit, predefined rules and logic that humans write and manage. Success is binary. Once the code is deployed, tested, and it's functioning as intended, it's considered stable. It's essentially done.
Right. You patch it, you update it, but the core logic doesn't really change.
Exactly. It either works or it doesn't. The rules are set.
Okay.
AI projects, in contrast, are inherently non-deterministic. They're intensely iterative. They aren't defined by fixed rules that humans write. They're defined by the data they're trained on. And they exist in a constantly evolving, often chaotic operational environment.
That distinction feels critical.
It is, because it introduces a concept that traditional IT project managers often overlook, and it's responsible for the majority of long-term value loss. Model drift.
Model. Okay, that sounds like a classic technical problem, but I want to connect this to value. What does this technical reality mean for, say, a CFO or a business unit leader in terms of lost revenue or wasted investment?
It means that the model's performance is perishable. It often starts to degrade the moment it's deployed. Think of an AI model trained on historical data, say, customer behavior from Q1 of 2024. That model will inevitably become less effective as soon as real-world conditions change.
So, consumer tastes shift. A competitor launches a new product.
A pandemic hits, regulations change, the economy shifts, or even something as simple as an internal operational procedure gets updated. Anything.
So the model literally drifts away from reality because the data patterns it was trained on no longer accurately represent the present or the future.
That is the core insight. If you launch a project and then you walk away, assuming it's done like a traditional IT system, which is a very common mistake, you are essentially guaranteeing its failure down the line.
And a traditional system just needs maintenance, maybe security patches.
Right. An AI system, however, requires continuous, proactive monitoring. It needs immediate retraining and constant tuning just to remain accurate and effective. If you aren't building the organizational rigor and the operational processes to manage drift, you're not building a durable asset. You're building technical debt that just compounds over time.
So the high failure rate is a direct symptom of applying an outdated, stable mental model to a whole new class of technology that demands continuous evolution.
That's it, exactly.
That sets the stage perfectly. So the problem isn't the AI itself, it's the management structure and the mental model we're applying to it. If we look at that 85%, we can probably trace their systemic failure back to specific organizational shortcomings. Let's explore that chain of failure that results from prioritizing procurement over a clear, measurable business purpose.
We absolutely can. We can trace the 85% failure rate back to 5 critical flaws, all stemming from that initial incorrect technology-first mindset, and they're all interconnected. They often set off a devastating chain reaction.
Okay, let's start at the top, which is often where the entire strategy originates and then breaks down. Flaw. #1. Leadership lacks the paralysis of unrealistic expectations.
This is fundamentally a failure of incentive alignment and communication. Executives, they're often swayed by the immense hype and promise of AI. I call it the magic wand analogy.
Right.
They believe it can solve complex, systemic, decades-old problems instantly. And they believe this without a clear understanding of the massive, resource-intensive effort required for data prep, model training, and continuous governance.
So they misinterpret the problem, which leads to these inflated, unrealistic expectations for the time, budget, and resources required.
And this often translates into what you call chasing shiny objects. Executives are incentivized to launch ambitious, innovative projects for competitive differentiation. even if those projects aren't anchored to the organization's most painful, value-generating problems.
They want to be seen as cutting edge. It's about perception.
Exactly. And at the same time, what happens is that the technical teams, the data scientists and engineers, they're motivated by professional curiosity. They want to work with the latest cutting-edge tools.
The newest large language model, the most complex reinforcement learning platform.
Right. To pursue technologically complex solutions, even when a much simpler statistical model might solve the actual business problem more effectively.
Okay, wait a minute. Isn't that a little naive, though? You said the failure isn't technological. But if I buy, say, GPT-4 and it fails to deliver value in my customer service center, doesn't that prove the technology wasn't the right fit? Or maybe that it's just too immature for enterprise use?
That's a critical challenge, and it clarifies the distinction. The technology can work in a vacuum, but if the business value wasn't clearly defined beforehand, then the application of that technology is flawed. The fatal issue is this. Neither the leadership's primary incentive, which is innovation, nor the technical team's incentive, which is complexity, is tied singularly to delivering tangible, quantifiable business value.
And that's the vicious cycle. Leaders want innovation, technologists want complexity, and nobody is singularly focused on the proof of value. So when the project inevitably fails to deliver on those inflated expectations because the business problem wasn't clearly defined from the start, it's abandoned.
And the budget is wasted, not on a technical failure, but on solving the wrong problem. This fundamental lack of a shared, measurable definition of success cripples the project before the first line of code is properly integrated into the business flow.
The anchor has to be a quantifiable business objective. If you cannot articulate the value, you just shouldn't start the project, period.
And that failure of definition leads us directly to the next flaw, which deals with the necessary fuel for any AI initiative.
Which brings us to the actual fuel of AI, or the lack thereof. Flaw, #2. The data dilemma why data quality is mission critical.
Data is the foundation, and if the foundation is flawed, the structure collapses. Guaranteed. A 2023 McKinsey report found that a shocking 70% of AI projects fail specifically because of issues with data quality and integration.
70%. That's a huge number on its own.
And it gets worse. That same report found that poor data quality costs organizations an average of $12.9 million per year.
$12.9 million. That's a huge anchor dragging down any potential ROI. How does that cost actually manifest? Where does that money go?
It manifests in a few ways. Through rework, through time and market delays, and through just flawed decisions. If data quality is poor, if it's incomplete, inconsistent, or unintegrated, data scientists spend 80% of their time on what's called data janitorial work instead of actual modeling.
So you're paying a top-tier salary for a brilliant data scientist to just clean data. That's a massive waste.
A massive waste. The Range report calls data engineering the dirty work. It also leads to delayed project launches, which means delayed value capture. And even worse, it can lead to inaccurate model outputs that result in bad business decisions, costing millions more in the market.
But organizations have been managing data quality for decades. We have sophisticated tools for cleaning data. Why is AI data so much harder to manage than, say, the traditional data we use for financial reporting?
Because for AI, data quality is a whole lot more nuanced. We need to distinguish between traditional data quality and this concept of AI-ready data. Traditional data quality focuses on accuracy and consistency, for basic analytics, compliance, summing up a balance sheet.
Right.
AI-ready data, however, has to meet 3 specific high-bar criteria. First, it must be fit for purpose for the specific use case. Data collected for accounting is useless for predicting customer sentiment.
Okay.
Second, it must be representative enough to ensure the model isn't biased and doesn't exclude specific customer segments or operational scenarios. And third, it has to be dynamic. It must be continuously fed and updated to adapt to changing real-world conditions, which is how you mitigate drift.
So you might have perfectly clean customer transaction data from the last decade, but if that data doesn't represent how customers behave now, or if it excludes a key demographic your new campaign is targeting, it's useless for a predictive model.
It's clean, but it's not fit for purpose. Precisely. And this leads to a cultural failing. Data engineering, the plumbing that handles all this complexity, is often undervalued and under-resourced. It lacks sufficient talent, which leads to knowledge loss and ballooning costs. Trying to build an advanced AI system without prioritizing a data-first culture, well, you're building the project on a foundation of sand.
Yeah.
You can't solve a data problem with an algorithm.
Okay, so if data is the fuel, then the human element, the organizational structure, and the people using the tools is the engine that has to process it. And that brings us to the silent killer of these projects, flaw, #3, organizational impediment, cultural resistance, and skills gap.
AI adoption is, at its core, a major exercise in organizational change management. Companies mistakenly treat it as a simple technical deployment when it should be treated as a cultural transformation. It's a fundamental redesign of workflows.
And if you don't have a structured change plan, it's doomed.
It guarantees low adoption and failure, even if the model itself is technically perfect.
We hear constantly about the massive AI skills gap. We know only about 1 in 10 global workers possess the necessary skills right now. That's a huge talent chasm.
It is, but the problem goes deeper than just hiring. You have significant employee resistance that's driven by a fear of job displacement or just a lack of trust in the technology, especially if the AI is deployed without transparency or communication.
Right. If leaders fail to communicate AI's role clearly, if they frame it as a threat rather than an augmentation tool, and if they don't provide adequate training,
Then the most sophisticated AI tool in the world ends up deployed as an optional extra.
meaning people just sidestep it, right? They continue using their old, comfortable, inefficient workflows because they either don't trust the new tool or they haven't been trained on how it actually helps them.
That's absolutely right. The technical teams operate in silos, the business unit doesn't trust the output because they don't understand the model's logic, and the tool never gets integrated. So you have these technically successful models that are rendered useless because the human factors, the fear, the ambiguity, the lack of collaboration, the failure to answer what's in it for me, for the average employee, were all ignored.
Okay, flaw number 4 addresses the cost of not building for the long haul. The strategic error of focusing on the prototype rather than the production environment. Flaw. #4. Technical debt trap underinvesting in durability.
Technical debt in AI is an inevitable consequence. It's a reality of the dynamic environment we discussed with model drift. But unlike traditional software debt, which is often a choice like cutting corners to meet a deadline, AI debt is a feature of deployment. Your model will degrade automatically over time. Managing this requires a robust, scalable infrastructure.
Okay, I'm thinking from the CFO's perspective here. I just approved a pilot that showed great results, promising millions in savings. Why am I now being told I have to spend more money on plumbing and monitoring infrastructure instead of just launching the model? Talk me through that trap.
It's a very reasonable question, and it speaks to the fundamental miscategorization of AI investment. Most organizations prioritize the exciting part. The pilot, the prototype, the proof of concept. They focus on the quick win, and they drastically underinvest in the unsexy foundation of data management and model deployment infrastructure, what we often call MLOps, or machine learning operations.
So they're putting 90% of the budget into building the race car engine, the algorithm, and only 10% into the pit crew, the fuel line, and the tires.
That's a perfect analogy, and it leads directly to the infamous last mile problem.
Yeah.
The last mile problem is when a successful prototype, which looks amazing in a demo because it ran on clean, isolated data over a short period, cannot be scaled into a production-ready system. The infrastructure needed for ongoing governance, continuous data processing, and rapid model updates is just missing. You built a powerful algorithm, but you forgot the operational discipline required to keep it fed, accurate, and relevant 2-7. You turn an inevitable challenge, model drift, into a catastrophic system failure by failing to build the rigor to manage it continuously.
And finally, we address the systemic risk created by this speed and fragmentation. Flaw, #5. The governance gap. The peril of fragmentation.
The speed of AI adoption has been so rapid, often driven by competing business units or even shadow IT, that governance and regulatory frameworks have really struggled to keep up. This results in what you could call a Wild West approach: fragmented systems, models deployed without clear ownership, and an inability to manage transparency and bias. AI governance is inherently more complex than traditional data governance because you're managing opaque, probabilistic decision-making.
So instead of a centralized managed infrastructure, you have different teams launching different models on different data stacks, all operating without any visibility from the enterprise level.
That's the fragmentation. And the consequences are severe. Lack of proactive governance leads to reputational damage, financial penalties, and operational failures. Organizations often view governance as this overwhelming burden or a reactive compliance checklist you tick off after the fact.
Right.
But the strategic shift must be profound. Governance must be seen not as a drag on innovation, but as a proactive, ethical design tool. It builds trust, it ensures accountability, and guarantees the long-term sustainability of the AI initiative. You just cannot capture durable value without durable trust.
So the 85% failure rate is caused by those 5 fatal flaws, all stemming from a technology-first approach. Then the only way to capture the immense proven potential is to fundamentally reorient. And this requires adopting a strategy-led framework built on 5 core principles that directly counteract those flaws. Okay, this is where we lay out the actionable plan for our listener. This is how you move into that 15% bracket. Let's start with the immediate counter to the leadership labs. Principle 1, define the business problem. First, focus on proof of value. POV.
This is the foundation. You have to eradicate the mindset of, I bought a cool tool, now what can I do with it? And you replace it with, what is the single biggest, most expensive problem we are trying to solve?
Start with an in-depth needs assessment to identify specific, measurable challenges.
Like, is it reducing the time it takes to process insurance claims by 40%? Is it improving customer retention by 5 percentage points next quarter? You identify the problem before you even look at a solution.
Exactly.
And the critical shift here is moving the entire focus from a proof of concept, a PAC, to a proof of value, a POV. So if I can build a model that predicts customer churn with 90% accuracy, that's a successful POC, right? Why isn't that enough? Why do I need to worry about the POV? That's the difference between feasibility and economic reality. A POC is a technical test. Can the AI model perform the task? It just tests technical feasibility. A POV is a business validation. It directly addresses the CFO's concerns. If the model predicts churn with 90% accuracy, what is the measurable, quantifiable economic impact on our revenue? And is that return greater than the cost of deployment, maintenance, and retraining over 3 years?
So the POC proves it's possible, the POV proves it's profitable.
Exactly. POV forces you to build a compelling business case anchored to a real metric. You might find that achieving that 90% accuracy requires a hugely expensive, constantly evolving data pipeline and GPU infrastructure, and the cost of deploying it actually outweighs the cost of the churn you prevent.
And if you can't define that value, you stop the project right there, saving a huge amount of investment that would otherwise just turn into failure debt.
Right. This principle ensures every AI initiative is tied directly back to the business outcomes that matter most.
Moving on to address the data dilemma. Flaw number 2. Principle 2. Implement a foundational data strategy context is king.
This means understanding that clean data is necessary, but it's not sufficient. It has to be contextually relevant. We can look at the cautionary tale of Google flu trends. It was a brilliant concept that ultimately failed because it relied solely on search query data.
Right, I remember that. It wildly overestimated flu cases.
It did, because it didn't account for the real-world context of media hype and general news coverage driving search traffic, even when the flu wasn't actually spiking. The data was clean and relevant to search behavior, but not contextually relevant to public health reality.
And the IBM Watson Health example trained on synthetic data that further highlights this limitation.
Absolutely. IBM Watson Health promised these revolutionary oncology treatment plans, but it largely failed because it was trained on limited synthetic data instead of the complex, highly nuanced data you find in real-world patient records. Synthetic data is clean and plentiful, but it inherently lacks the messy, crucial variations that define real patient responses. The data just lacked the necessary context.
So the action required here is moving past mere data cleaning and into strategic data acquisition and management.
Correct. And to achieve this, organizations must establish 2 actionable components. First, deep collaboration with domain experts, the doctors, the oncologists, the logistics managers, to ensure the data truly reflects operational reality. And second, establish clear data lineage. You need to be able to track data sources, transformations, and usage for transparency and compliance. Data lineage gives you that chain of custody for your data, which is essential for diagnosing model failures down the road.
You're building an AI-ready ecosystem that prioritizes relevance and context over just mere volume.
Exactly.
Okay, principle number 3 is about integrating AI into the DNA of the organization, solving flaw, #3. Cultivate an AI-first culture, multi-tiered leadership.
Cultural transformation has to start with visible leadership commitment. Senior leaders must champion AI, not as a cost-cutting measure, but as an augmentation tool, a partner that enhances employee abilities, not replaces them. That sets the vision and alleviates the existential fear of job loss, which is the root cause of so much resistance.
But the vision has to meet the road, right? If the C-suite mandates it, but the average frontline manager doesn't buy in, the whole thing just dies.
Absolutely. The success of AI hinges on a multi-tiered leadership strategy. While senior leaders set the tone and fund the initiative, mid-level managers are the crucial implementation pivot. They sit between the strategic directive and the frontline operations. They are the ones who must be empowered and educated to embed AI into the daily workflows and foster that cross-functional collaboration.
So structured training and reskilling programs aren't just for data scientists. They're essential for mid-managers so they can understand how AI helps their team achieve its goals and how to adjust workflows around it.
Precisely. Developing these AI-first capabilities at the management level is what turns a strategy into an operational reality. It shifts the culture from passive resistance to active engagement.
Principle 4 addresses that inevitable technical debt trap, or flaw, #4, build for scale and durability proactive model management.
A strategy-led approach plans for the long term. It plans for the inevitability of model drift from day one. This means proactively investing in robust infrastructure for data management and model deployment, what we call MLOps, before the pilot is even completed. This prevents the last mile problem.
Let's get a little granular on MLOps. How is that different from traditional DevOps, which a lot of our listeners will be familiar with?
It's a great question. Traditional DevOps manages static code deployment. Once the code is deployed, it rarely changes unless a new feature is requested. ML2s, however, formalizes the continuous loop of testing, monitoring, and retraining that manages drift. It's the entire operational discipline required for a non-deterministic system. It includes automating data ingestion, checking for data quality, monitoring model performance, and automatically triggering a retraining sequence when performance degrades.
So we stop thinking of this as a temporary capital expenditure and start treating MLOps as an ongoing essential operational discipline, like cybersecurity or core IT services.
Exactly. And leveraging cloud platforms is essential here, not just for storage, but for the flexibility and scalability needed for intensive, continuous data processing and rapid model retraining. And the most vital component is implementing continuous monitoring and feedback loops. This proactively detects and mitigates degradation in model performance due to drift. You're building a system designed to evolve alongside the business.
Finally, addressing the governance gap. Flaw, #5. Principle 5. Embed responsible AI from the start, ensuring trust.
Governance has to be integrated into the project foundation, not bolted on at the end as some compliance afterthought. This starts with assigning clear ownership for AI governance. Specific teams or individuals must be accountable for model outcomes and adherence to ethical guidelines.
And this shifts the focus from reactive compliance, waiting for a failure to fix it, which leads to reputational damage, to proactive ethical design.
Correct. The goal is to build transparency and accountability by implementing what we call explainable AI, XAI. If stakeholders, whether they're customers or internal auditors, can understand why an AI decision was made, for example, why a loan was approved or denied, trust increases, resistance drops, and the long-term risk of legal challenges is mitigated.
So responsible AI isn't just about being a good corporate citizen. It's a strategic risk mitigation tool that secures long-term sustainability.
Absolutely. Trust is the currency of long-term value, and governance is the mechanism that generates and protects that currency in the AI era.
Seeing these strategies in practice really provides the clearest definition of success and failure. The flaws and the principles suddenly become tangible when you see the results on the balance sheet. Let's start with a deep dive into a really high-profile cautionary tale: the spectacular failure of Zillow offers.
Zillow's foray into the iBuying market, using AI to predict property values and facilitate rapid home flipping. It was driven by immense ambition. They had access to enormous amounts of clean, standardized housing data, and yet their model fundamentally failed.
It was a perfect storm.
A perfect storm, illustrating multiple flaws in action.
So what went wrong specifically? The model must have been highly accurate at the prototype stage for them to bet so big on it.
The problem was the sheer complexity of the real estate market, which is incredibly localized and dynamic. Zillow's algorithm consistently overestimated property values, particularly during periods of market fluctuation. Zillow ended up significantly overpaying for homes, which they then had to sell at a loss.
That failure is a textbook case of combining the technical debt trap with the leadership lapse. How did that model drift actually manifest itself?
The model drift was relentless and was unmanaged. Real estate market data, especially at the local neighborhood level, has a very high velocity. Zillow's model was likely trained on aggregated, delayed data, meaning it was always operating slightly behind the curve. It couldn't keep pace with the dynamic shifts, the geographic differences, or sudden market corrections. It just wasn't built with the MLOps rigor to handle that volatility.
Bad result.
Catastrophic. Zillow ended up with a massive inventory of overvalued homes, ultimately leading to a $500 million loss and the complete closure of the Zillow Offers business unit. And that wasn't just $500 million in losses, that was people's jobs and market confidence, all because of an invisible algorithm failure.
It perfectly illustrates the cost of underinvesting in durability flaw, #4 and strategic overreach flaw, #1, by failing to validate the POV against real-world risk and market variability.
Now, contrast that failure with the success stories. The organizations that apply this strategy-led blueprint. Let's look at Unilever's Unabot.
Unilever's goal was far less ambitious than Zillow's, which is perhaps the key to its success.
Precisely. Unilever faced a specific, well-defined business problem, efficiently onboarding massive amounts of new hires across 36 countries. This process was overwhelming, inconsistent, and resource-intensive. They didn't start by saying, we need an AI platform. They started by saying, we need to solve this onboarding pain point in a measurable way.
And the result was Unabot, an AI assistant. How did that demonstrate proof of value?
Unabot succeeded because it flawlessly executed two core principles. First, Principle 1, define the business problem first. It solved a specific, tangible, and measurable pain point, reducing the time and resources spent answering repetitive questions. The value was immediately quantifiable in terms of HR staff time saved and faster time to productivity for new hires.
And what about the culture piece?
Critically, Principle 3, cultivate an AI-first culture. By solving a real, painful, day-to-day problem for employees and seamlessly integrating into existing workflows, Unabot achieved a very high adoption rate. Employees perceived it as a valuable tool that augmented their processes, not as a replacement. That acceptance transformed potential resistance into enthusiasm.
Our second exemplar, IBM's internal AI training, showcases how a company can solve its own organizational impediments using its own technology, directly confronting that cultural flaw.
Right. IBM used its Watson platform to confront a massive internal challenge, the AI skills gap among its existing workforce. Flaw, #3. They had the strategic realization that they couldn't just hire enough new talent, they had to reskill the talent they already had. But generalized training is often inefficient and poorly adopted.
So they treated their employees' career development as an AI optimization problem.
Exactly. Instead of demanding employees find training externally, they use Watson to analyze employee data job roles, existing skills, past training, future business needs, and created personalized learning paths.
That's a powerful illustration of Principle 3 in action. They directly addressed cultural resistance by positioning AI as an essential tool for career growth and relevance, not redundancy.
It's the ultimate example of augmentation. By using AI to empower employees and help them acquire new high-value skills, IBM turned what is often a point of organizational friction, the fear of irrelevance, into a source of enthusiasm and organizational success. They invested strategically in their people, demonstrating that AI is designed to help them succeed. And that's far more powerful than any top-down technical mandate. And we really need to reiterate the central takeaway of the AI value paradox here, that low 5.9% average ROI. It's a statistical illusion. It's a number dragged down by the 85% of failed strategy-less projects that were based on hype. The true potential, that 3.7x to 10.3x return, is being unlocked by the successful strategy-led organizations that follow this blueprint.
And we need to help the listener articulate this value internally. If you're going to secure budget for one of these strategy-led initiatives, you need to break down the realized value into clear, quantifiable returns. We can quantify those returns in two major complementary categories. Let's start with hard ROI.
Hard ROI represents the measurable, direct financial benefits that hit the balance sheet. This includes quantifiable labor cost savings from automating repetitive tasks, clear efficiency gains in processes like Unilever's faster onboarding, and higher profits from optimized customer experiences.
Let's use a specific example of that hard ROI chain reaction. In manufacturing, we discussed AI-driven predictive maintenance.
That's a perfect example. Predictive maintenance can cut machine downtime by 20 to 30%. And this isn't just about avoiding a break, which saves maintenance costs. The hard ROI cascades. Less downtime means millions of dollars saved annually in increased production throughput. It also means you can reduce your required spare parts inventory by 15% because your forecasting is reliable.
That's a direct reduction in capital tied up in inventory.
Exactly. And furthermore, knowing machine life accurately allows you to plan capital expenditure for replacement strategically, avoiding those high emergency replacement costs. It's a direct, measurable financial impact that justifies the entire investment.
Okay, now we also have to consider soft ROI. While these benefits are more indirect and qualitative, they are absolutely crucial for securing that long-term, durable, competitive advantage that the successful 15% realize.
The challenge with soft ROI is articulating its financial gravity. The best examples are things like higher employee satisfaction and retention. That's a direct outcome of augmentation-focused initiatives like IBM's internal training. When employees feel supported and upskilled, they stay. And that reduces recruitment and training costs.
And what about the market perception side of things?
That's where governance, Principle 5, really comes in. A stronger brand reputation, secured by proactive, transparent, ethical AI design, reduces your regulatory risk exposure and increases customer trust. And while you can't put a direct dollar figure on a better reputation tomorrow, that resilience and agility fostering a culture of learning and continuous adaptation are what fuels sustainable growth. Agility is the ultimate soft ROI.
So by adopting the strategy-led framework, organizations shift their focus entirely. They move away from managing the crushing risks and costs of the 85% failure rate and toward unlocking the immense proven value realized by the successful 15%. This is really the only path to realizing AI's transformative potential. This deep dive has shown that the challenge is not insurmountable. The technology works. The execution model is profoundly flawed. Corporate leaders have to shift from that high-risk, procurement-centric model to the strategy-led blueprint we laid out. Define the problem first. Implement a foundational data strategy. Cultivate an AI-first culture. Build for scale and durability using MLOps. And embed responsible AI from the start.
The failure rate proves that technology alone is not enough to generate durable value. For you, the listener, the ultimate differentiator in the AI era is not the cutting-edge model you choose to purchase or the size of your GPU cluster. It is the operational discipline you build, the rigor to manage data lineage, to foster a culture of augmentation, and most importantly, the discipline to continuously monitor and manage model drift.
That organizational rigor is what transforms AI from a high-risk, wasted investment into the robust, evolving engine of a durable competitive advantage. It's not about the model, it's about the management model.
Indeed. Ask yourself this provocative thought. If 85% of projects fail because they ignore the operational necessity of managing continuous change and drift, are you investing in a one-time deployment, which is doomed to degrade? Or are you committing to a permanent, evolving operational system that's designed to deliver value year after year? The organizations that master the management of AI are the ones that will secure the sustainable profits of the future.
That's it for this episode of the AI Value Paradox. We hope these insights help you look at AI within business through a new lens. If you're ready to stop the guesswork and start seeing real results, click the link in the description. We'd love to connect and help you build a custom solution that moves your brand forward. Thanks for listening, and see you in the next episode.